Here's our math problem for today. Let's say we have this circle O and we draw these two line segments AB and CB that are perpendicular with each other. Suppose that the length of segment AB is 8 meters and the length of segment CB is 4 meters. We would like to find the length of the radius of circle O. You can pause the video and see if you can solve this geometry problem. Now let's solve this problem together. There are two methods that we are going to use in order to solve this problem. The first method is we are going to use the Pythagorean formula. Let's begin by connecting points O and C to form this line segment, which is also a radius of circle O. So we now have here two radii. Segment AO is a radius, segment OC is another radius, and let R be the length of the radius. Let's also assign a variable S for the length of segment OB. From this figure, we know that if we add R and S, the result would be the length of segment OB, which is given to be 8 meters. Solving for S, we subtract R from both sides, so S is equal to 8 minus R. Now, in order to use the Pythagorean formula, let's look at this right triangle here. R is the hypotenuse, S is one of the legs, and we know that the measure of the other leg is 4 meters. So we can now form this equation. The square of the hypotenuse minus the square of one of the legs is equal to the square of the remaining leg. But we know that S is equal to 8 minus R. So we replace this S by this value of S. Then we square this binomial. The square of 8 is 64 minus twice the product of 8 and R to get minus 16R plus the square of R. All the rest are copied. To remove this grouping symbol, we multiply each of the terms inside the grouping symbol by -1. So this becomes negative 64, this becomes positive 16R, this becomes minus R squared. Everything else are copied. Now, simplifying this R squared minus R squared is 0. Then we can add 64 to both sides of the equation to arrive at 16 plus 64 at the right side, and we just copied 16R. 16 plus 64 is 80, and dividing both sides by 16, we have R equals 5, and the unit is meters. So we already know that the length of the radius of circle O is 5 meters. Now, another way of solving this problem is to use the power of a point theorem, which says that when you have two chords intersecting inside the circle, then we can use this formula. The product of AP, which is this line segment, times DP, which is this other line segment, is equal to the product of BP, which is this line segment, times CP. In other words, if we can form two intersecting chords here that intersect inside the circle, then we can use this formula. So let's extend segment CB in the direction of B, and let's call this point as D. CD is a chord of circle O. Then let's also extend segment AB in the direction of B, and let's call this point as point E. AE is a diameter of the circle. That is because it passes through this center. Now, based on the power of a point theorem, we can now form this equation. The length of segment AB times the length of segment BE is equal to the length of segment CB times the length of segment BD. Now, we need to find what is the measure of segment BD to be able to use this formula and find the value of the radius. So let's recall some properties of a circle. The perpendicular dropped from the center divides a chord into two equal parts. Now, so that we can apply this property in our given circle here, let's reorient the circle at the right. Notice now that this chord here is our chord CD. From the center, we drop this perpendicular that is equivalent to this line segment here from the center O, perpendicular to the chord CD at point B. And based on the property, this line segment here is congruent to this line segment here. So if this is 4 meters, then the measure of segment BD must also be 4 meters. And finally, let's assign a variable for the measure of segment SE, and let's call it as T. So we now have these values here. Then substituting now these values to this formula, we have AB is equal to 8 meters, BE is equal to T meters, CB is 4 meters, and DB is also 4 meters. Simplifying, we have 8T is equal to 16, and divide both sides by 8 to arrive at T equals 2 meters. So we now know that the length of segment BE is 2 meters. It was given that the length of segment AB is 8 meters. So the diameter of our circle O is 8 plus 2 or 10 meters. And when we know the diameter divided by 2, we have the measure of the radius, which is 5 meters, which is also consistent with our previous result. So in both ways, we arrive at the same answer, 5 meters for the radius of this circle O. Thank you very much, and we hope to see you again in our next video. Bye for now.